This video is brought to you in part by TruTech Tools, quality tools, essential support.
Alright guys, so we're back over in this Conair. I did a video of that piece of machinery down there, and we finally just got the TXVs okayed. So what we got going on here, we had a problem with the flow switch. So somebody put a new flow switch on it. I come back and I go to put a flow switch on it too. And I'm like, wait, that's 23 date code. That's the new one because I switched them. I'm like, what's going on here? So I hook up a new one after making sure that my voltages were correct. So on this plug right here, one is positive, 24 volts DC. 3 is your negative. 4 is your milliamps coming back to your control, and 2 is nothing. I had 23.9. I hook it up. It worked. I'm like, oh, great. I can get out of here because today's Saturday. I had flow. It worked for a little bit, and I'm checking my milliamps here because you put it in series, which is where I have the jumper at now, and it went away. And then it came back, and it went away. It came back. And I'm like, oh, I guess I ain't leaving. So next thing I know, I'm like, okay, let's see what my actual device is pulling, because luckily they gave me some basic information here. Shouldn't pull no more than 80 milliamps. I'm like, okay, that ain't good. And you know, at least this time I have a freaking schematic for it. And this sensor's German made. You know, those never go bad. So I put the old one in and it starts working too. And I check my load on it, so that's working. Basically, it ain't got the correct flow. And you would think, you know, you've got full-time maintenance guys here, they might freaking check the strainer and not just open up this stupid valve here. But unfortunately, they didn't. I'm gonna show you the still picture because I wasn't gonna record this crap at first. You can see I flattened this back out with my sledgehammer and a round pipe because somebody jammed this stupid thing back in there. See, this goes in there like this. And that helps keep the flow as it's coming in. It goes through this thing and then goes on through. So you're basically having to go all around that, okay? And then it goes on out that side. So basically, it's gonna get trapped on the inside here, and it could go a little bit here. So when you open this up, here on the center, as you can see, it lets just water come out. That ain't cleaning the filter. They shouldn't even have this on there. That's stupid. Doesn't clean out the filter. So as you can see, somebody smashed it in there, so what I had to do is flatten that back out. So I'm gonna get in there and clean that a little bit better. And then this thing comes on behind it, goes into those grooves, and that will filter it. So, say the least, this other one's short cycling. I guarantee you that it's got the same flipping issue here, because you look at this water, it's garbage. Look at that. That is garbage water. It's not being treated. And what's bad is this is on the source side, the load side, going to the actual machine, which is out there. So you're gumming up your machine, you're gumming up the plate heat exchangers. Absolutely crazy that this wouldn't be treated, maintained, filtered. I mean, I'm sure those machines cost $3 or $4 at least. But this thing has had nothing but problems from what they tell me from the very beginning. And you know, the one circuit there's running, I forced all the flow through it just to, you know, while I did some checks and stuff, and that's when I found all this out. That's what we got so far. We're gonna put it back together here and see what we got, and see if we made progress. All right, so we put it back in there, and I tightened this one up first, then tightened up that one. We did the little tappy-tappy and got the tappy-tappy into the inside here. Wasn't perfect, but I went ahead and equally crushed it in there. Hopefully it didn't smash it much, but at least we did the attempt at making it straight. We got our valves open here. We are not leaking right now. I think I'm gonna go ahead and enable my compressors here. Now, like I said, this machine's completely new to me. I haven't really done much with it. But eventually you figure it out. User setup, compressor staging, see staging down here, little pokey, and eventually you get around to it. So here's disabled. We just enabled stage 1 and 2. Let's see if this thing actually runs now. Now you come back up here to diagnostics, and you can see circuit 1. And let's see if my saturated suction temperature doesn't take a dump like it did last time, because it dropped down below 20 degrees in like no time flat. So as soon as this thing gets started, we got a countdown. Here we go. It should be about ready to go. So let's get back up 1, 2. See if it kicks on. It's not running yet. Oh, there she goes. All right, we're gonna fail out. What are we gonna get? Evaporator temp, suction temp, we're 38. Come on, baby, stay up there. 25, uh-oh, it's not gonna work, is it? Can you come back up? You got a little delay there. See how our EXV is. It looks like it's full. You can come over and actually see what that's doing. Subcooling, we got 19 degrees subcooling there. Discharge saturated, it's 85, so not looking good. Suction saturated, 34 degrees, I like that. Suction temp 71, superheat 35, not flooding out. EXV's 33, which tells us we're not wide open to try to achieve these things, which is a good thing. Compressor 1B is on, that's a good thing. We come over, we see we got flow. B is counting. I don't know if that's the first time it's counting. It might be, it may have already messed up once, I'm not sure. So we go over here to input outputs. We can go to inputs, which is our flow switch. And circuit 1 flow switch right here, it is on. That's good. Now what I'm gonna do is I'm gonna go in here and I'm gonna shut this other circuit off. I guarantee you, what you didn't do to one, you're probably not gonna do to the other. So let's go over here to setup. Let's go into compressor staging, and let's scroll over to circuit 2, disable, disable. Show shut down, there we go, good deal. They're off, good deal. They're hot. Let's go ahead and shut this off. There we go. There we go. Would you guys rather see this kind of stuff, or would you rather see a reaching cooler? Let me know down below. I think we've prepared enough reaching coolers and rooftop units. Not everybody does it. One of the benefits of being where I'm at. So just leave a comment down below. Let's go ahead and relieve some pressure off of it. There we go. We know that's not doing anything. So we go ahead and get rid of that. Let's take this puppy apart and see if that thing's gummed up. Let's go over here. I try to keep my tools together. That way I don't forget them. All the maintenance dudes are gone. Nobody really here except for machine operators. There we go. A little jump there. Little jump there. There we go. Woo! Unfortunately, getting a little something on the ground. Not much I can do about that. It is what it is. At this point, the unfortunate thing is they have a tendency to call only on the weekends, and this was needing checked, I think, since November. So my feeling is we're gonna do whatever it takes to get this thing running, get a little something on the floor, because there really ain't a whole lot of place to put it. I don't know where everything's at. It is what it is. Make sure there's not something leaking through. It took a little while before, but now these plate heat exchangers probably are gummed up full of crap. And once they plug up, I've never cleaned one, but I've been told they are a mother of mothers to clean, and a lot of times they don't clean up. So we got that there. Give it a little shaky of the hand. There we go. This screen's not as bad, hence why it probably wasn't triggering out. However, if you take a look in there, it does have some crap. So, you know what? We're gonna clean it out. Go ahead and get her cleaned out. I forgot to grab my Leatherman. I only may try to clean it out. There we go. That one's not that bad. But you know what? I'm gonna clean it out because we do have some frog skin in there and whatever else you wanna call it. I think I'm gonna buy another pair of those side cuts. These Crescents, man, they got some grip to them. See, this crap is what's getting in their plastic machines. That's what's bad. That is bad. Now, see, the way this works, okay, this device over here is your pumps. There's 3 pumps on it. This pump here pumps it up, comes up, over, comes into the top of these heat exchangers. Comes out, comes back over, comes down into this barrel. This big barrel here is like a surge tank. I forget the exact name. But basically, it's like a primary heat exchanger. And it, you know, on like a boiler, primary, secondary. So this one here just stays cold. Over here, this pump, this is the pump that takes it out to the machines that need the cool water that are making the plastic devices out there, the blow molds. So it sucks it up from the bottom, just like that one did for the chiller. And this one here picks it up, blows it through, has a bypass here, goes through this filter and up, out, and up to those big old pipes, which then go on out there to the machinery. But, you know, I turned these on, check pressure drop. It didn't seem like it was that bad. But all that does, that water just circulates in there. You can kind of see in there. But look at that crap. It looks horrible. It looks like mud. So, I mean, it's kind of self-explanatory that, you know, if your water's garbage, you know, ever heard the old song, input, output, what goes in, what comes out? That's exactly what we got going on here. Bunch of garbage in, bunch of garbage out. Here's some of those machines, multiple different kinds. Come back here, and you can see all the garbage I got out of it the last time. See, those compressors have a short cycle delay, and because they don't want them obviously short cycling over and over and over, they put like a 200, 300 second short cycle delay on it. I don't know exactly what's kicking it out. Most likely probably a low evaporator temp, or it could be getting close to hit set temperature right now. The machinery now I think is starting to slow down. This is Saturday. I was on call for Christmas this whole week. Didn't have anything for Christmas. I have another video that I was going to make too, which was a questionable one if I wanted to show it or not, because of kind of a callback on somebody. But yeah, the screen is going to look a lot better. It's just good to verify. Trust but verify. My feeling is don't trust anybody, always verify. But you got to be positive, all sunshine and rainbows. My whole thing is trust nobody. Of course, there's only one person you can really trust, but you know, I think that's about as good as you're gonna get it. Look at that. I think that's about as good as you're gonna get it. Had to go to the shop, pick up the flow sensor. That took time. Remember this thing I worked on, it's holding 65 degrees. I still gotta come back and change these TXVs. Finally got it approved. They're over $1,000 some each. Kind of an expensive TXV. And this place is like highway speeds an hour and a quarter, hour and a half from my house. Not that city driving. So I'm gonna put the nicer looking edge. See how it's nicer that way? I'm gonna put that towards the flow going through. So let's get it the tappy. This is called the attitude adjuster. This is my cheater bar. See that? Tappy. Little tappy. We're hitting it evenly all the way around. That way we hopefully don't bend it all up. Good deal. Looks like we kind of in there. Very good. So a lot of the reason why a lot of people don't think show it. That and most people that do this don't want to show it. So to me it's just the same crap. Just different location, different size. Once you learn your basics, you can do anything. Understand the principles behind it. Those out there are probably going, he's making me sick. Turn it off. Okay, we're tightening this up. A little tightener, a little tighter, a little tighter. Yeah, I can hear the short cycling of that compressor. You just heard it shut off over there on my left. Okay. Now with this being an open pipe system, I mean it sucks it out of the bottom of that over there and blows it back in. There's no air to worry about, which is kind of nice. And I'm only on setting number 2 here. Go ahead and close that. I believe that should be taken out of here. So go ahead and open this one back up. There we go. Open this one up. Ugh. There we go. And that should be a big old burp over there to the other. So right now, we go to diagnostics, circuit 1. We're only running one compressor. Of course, you know, if we go to home screen, our set point is only 66. Or I should say our supply is 66, return 70. It is anti-cycling. Most likely, the freaking heat exchanger's probably got a lot of crap in it. Nothing I can do about that now, you know? There's not a lot I can do about it. That comes down to you should have been taking care of it to begin with, the way I look at it. Extra staging, go over one, enable. There we go. Let's go ahead and disable these two here. And now let's go ahead and hook onto that flow switch and let's see what we got. So, like I said, I kind of inserted that. Let's see if you kind of get a better look here. So some people said on one of my other videos, hey, make sure you've got a good connectivity in there. So what I did is I literally went and got my small prong sensor prongs here. I use this for low voltage. It's made for low voltage, I should say. You can actually stick that right into the prongs where the sensor's at. And you're wondering about the thumb. That was a vacuum pump, fell off of a walking freezer condenser when I was doing it out super cold, and it flipped and smacked my thumb. My battery operated one. I wanted to catch it, and boom! That's what happened. Now we can go ahead and switch this around. We'll put it back the way it was. I know now that that sensor's not getting fried, so we're gonna get the special little screwdriver in there. This one right here worked really well. It's very thin and long. It's able to get in here like this, get all the way to the back, and you can pull over, and when you do, you can pull the device right out like that. Undo that one. Go ahead and undo this one, and we'll go ahead and hook this back up to this here. Since this power theoretically is coming from the actual switch, flow switch, we need to be that direction there, otherwise it gives you a negative. And I need my other hand to get that in there. Alrighty, so we are getting some sort of milliamp reading. There we go. It's hooked back up. Let's go ahead and turn those compressors on. There we go. We go back to staging. So one should turn on here in a second. There we go. So compressor 1 is ready to go. Compressor 2. Yeah, neither one of these should be running just yet. Flow alarm, no. Flow okay. Must be working. Why am I not getting our signal? Oh, I'm on AC, that's why. There we go, DC. 3.56. I had 3.65 before, so we know it's working. I thought that sensor was defective. Fortunately, it's not. Yeah, we had a flow issue. You know, I guess I'm just as guilty as the first person that found it bad. We'll probably end up taking the one out that I just brought, and we will stick this in there. Something just kicked out. That theoretically is new. That's working. We've got flow. 1A and B, they both triggered out, but it's probably, I would suspect, because we're technically at supply. I don't know which one they're keeping off of, but it's actually able to run. We can come into that setup screen and probably tweak it. PDA, I'm sure there's some tweaking here you could do. It'd been nice I could have came over this when the factory was open. Set point, process temperature 63. If this was designed right and sized correctly, it should make it so only one runs, and that way it never shuts off one of them. But chances are that's not how it's working. I think we're at the point now where we at least aren't having flow issues, and she should be good enough. I'm going to tell them, hey, probably need to do a little work here on that other stuff, and there's the answering service probably to give me another call. All right, so here's what we got. I ended up increasing my stage DT, which I'm assuming is my differential temperature, to 2 degrees. I took the delay stage here from 120 to 540, which is like 9 minutes of delay. D stage DT stayed at 5, and the delay second D stage is 5, which I don't know. That seems like that's 120 max, so it really ain't no crazy amounts. I'd almost rather see that more like 30 or something, way it ain't just dropping out immediately, but chances are it's probably fine. So we're going to escape out of there. That's the only thing I'm changing. Now I have not seen any more issues with it dropping, anti-short cycling and all that. Well, maybe so, but maybe that's just because I just kicked it on. It might be because I just kicked it on a second ago. Yeah, I'm pretty sure that was just because I ended up getting it hooked back up, and that might be from when I just re-engaged them a second ago. You can see all of our fans are working now. We had some issues with that originally when I first came out here. Got that labeled, pretty much got it set so that they know not to trash it. I'm gonna get my goodies out of here. I'm gonna leave these little short stubs here so that we can actually do that again next time. And definitely pays to have some of these extra goodies on my meter and stuff there. So we're going to put this back inside there. That way they know, whoever comes along next time, they'll know what exactly things are rated at. Like I said, this right here is going to be very helpful. It's going to be me or one of probably 4 other guys that possibly could be here. This should help out a lot. Should help out a lot, I'm hoping. So right now, I mean, we're doggone close. I don't know what's the story with that. At this point, I've got a jail that's not working, so I've got to go look at that and see what's going on, some chiller. All right, guys, hopefully you enjoyed it. Until next time, catch you on the next one. Later.